Hello, everyone. Today we are starting Unit 9, Transformations. So our study of transformations is going to include rotations, which is a turn, reflections, which are a flip, and translations, which are a slide. We're also going to do dilations. So starting on page 3, Transformations Day 1. Today we're going to talk about reflections on the coordinate plane. So a transformation in general of a geometric figure. So we're going to explain how to use the transformation figures without the benefit of the coordinate plane can be difficult without some important vocabulary. So the word transformation has a specific meaning. A transformation f of the plane is a function that assigns to each point P of the plane a unique point Fp, or the function of P in the plane. Transformations that preserve lengths of segments and measures of angles are called two things. So they are a rigid motion or an isometry. A dilation is an example of a transformation that preserves angle measures, but not the lengths of the segment. In this lesson, we will work only with rigid transformations. We call a figure that is about to undergo a transformation the pre-image, while the figure that undergone the transformation is called the image. So let's look at 1 and 2. State whether each transformation appears to be a rigid motion. So when I look at number 1, it changed size. So the answer is no. The size changed. Number 2 is yes. Same shape and size. So first thing we're going to talk about is a line reflection. So for reflection, we need to know the line of reflection. We need to know the pre-image and the line of reflection. The line of reflection acts as the perpendicular bisector of each segment that joins a given vertex of the pre-image with the respective vertex of the image. So what we're talking about here is if I have a triangle and I reflect that over a line, I get a new triangle such that so that when I connect each point to the new point with a line, that line of connection is the perpendicular bisector. So each point would have a line associated with it that is the line of reflection is the perpendicular bisector. So those are approximately my new triangle. So if this was A, I say this is A prime, this is B prime, C prime. So that the line of reflection, which we can say is L, is the perpendicular bisector of the segment joining A to A prime, B to B prime, and C to C prime. Notation for a line reflection is lowercase r, and then below we write the line of reflection. So we would say the y-axis, x-axis. So let's see how we're going to do line reflections. So we're going to focus on line reflections in a coordinate grid. So if I have the point 2, -1, and I want to reflect that over the x-axis. So that means I want the x-axis to be the perpendicular bisector of the line connecting 2, -1 to its new point. So one way we can do it when we're talking about horizontal and vertical lines is we can simply count. So 2, -1 is one below the y-axis. So my new point is 2, +1, because that's one above. So then when I reflect over the y-axis, 2, -1 is 2 to the right. So my new point is 2 to the left. So that gives me -2, -1. When I reflect over the line y equals x, we have to remember that the line y equals x is a line that goes diagonal through the coordinate grid, has a y-intercept of 0 and a slope of 1. So when we're looking at our point, we want to draw a line from 2, -1 that is perpendicular and equidistant on both sides, so that the green line there is our perpendicular bisector. So perpendicular, that means we need to have a negative reciprocal slope. The slope of my green line, or y equals x, is 1. So starting from my red point, I want to do a slope of -1. So that would mean down 1, right 1. But that's not taking me towards my line. So I want to do the opposite. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. And I get this red line. Now I want this point to be equidistant. So we should use the midpoint formula, but we can kind of see that it's about 1.5 away. So if I go 1.5 away, I get this point, which is -1, +2. So the reflection of 2, -1 for the line y equals x is -1, +2. And then the last reflection I want to do is over a horizontal line, which I can do exactly how I did my x and y axes. So I'm going to start by drawing the line y equals 2. And now my point is 3 below that. 1, 2, 3. So my new point is 3 above it. 1, 2, 3. So my point is up there, which would be the coordinates 2, 5. So when we're talking about a horizontal line or a vertical line, we count how far we are and go the exact distance on the opposite side. So now I want you to pause and I want you to see if you can use our 3 examples that we did to come up with a rule for reflecting over the x-axis, the y-axis, and the line y equals x. So hopefully you noticed that when we reflected over the line y, the x-axis, our x-coordinate stayed the same and our y-coordinate became negative. So if we're doing that to the point AB, A is going to stay the same and B becomes negative. So the rule for reflecting over the x-axis is you keep the x-coordinate the same and the y-coordinate changes sign. Now when I look at over the y-axis, you can see that my y-coordinate stayed the same, but my x-coordinate changed signs. So AB over the y-axis would become -A, B. And then the last rule we should memorize is when we reflect over the line y equals x. So when we look at what happened when we reflected over the line y equals x, our coordinates flipped places. So AB is going to become B, comma, A. So now we're going to do example 1. So I want you to pause, and I want you to try number 1. So you're going to graph the triangle and then reflect over the line y equals x. Come back and check. So you can see I plotted my point A, B, C, and then I reflected over the line the y-axis, and I laid my new points A prime, B prime, C prime. When you're graphing these, you need to make sure you always label your coordinates, label the points, and then I also state my coordinates. Our next example here, so my final answer is A prime is negative 1, 6, B prime is negative 4, 3, and C prime is negative 2, 1. For our next example here, I want to reflect the point x, 0, 5, through the line x equals 2. The line x equals 2 is a vertical line going through 2 on the x-axis. So when I'm reflecting through that, I'm 2 to the left. So my new point is 2 to the right. So x prime is 4, 5. So now I want to take that new point, x prime, and I want to reflect it through the line y equals negative 1. So the line y equals negative 1 is down here. And my point x prime is 1, 2, 3, 4, 5, 6 above. So my new point is 6 below. 1. I'm going to name that x double prime. So x double prime is at the point 4, negative 7. And number 3, so I want you to pause and try 3 and 4 and come back and check. So on number 3, I reflected the line segment FG over the line y equals x, and f prime became 0, 3, g prime became 3, 4. Notice that my slope did change. It became the reciprocal. This will always happen with line segments. It's not the negative reciprocal, so they're not perpendicular. It's just the reciprocal. Now, when I do 4, this says to graph and find the equation of line of reflection. So what I've done is I graph both. So now I'm looking for the equation of the line of reflection. Well, I can see that A, B, and A prime, B prime are both vertical lines, which means my line of reflection is going to be the vertical line in between, which is the equation x equals 3, so that it's the perpendicular bisector of all the points. So that is x equals 3. So that is the end of our video today. If you have any questions, please ask me tomorrow in class.